Good evening, fellow Adelaideans, and welcome to the Climate Commission's Community Conversation. I'm Nance Haxton. I'm a reporter with ABC Radio Current Affairs for the national programs AM, PM and The World Today. My role tonight is to facilitate this fantastic opportunity you have to ask questions directly of our climate change commissioners. You may want to know how quickly the Earth is warming, what can be done about it, or you may be a sceptic of this entire climate change concept and you'd like this opportunity to ask the commissioners to explain their case. We'll try our best to get to everyone who has a question tonight and include you all. But please, we ask that you do keep your contribution to short questions only and not make sweeping statements. Before we start this evening, I want to acknowledge the traditional owners of this land. I'd like to pay my respects to their elders, past and present, and the elders from other communities who may be here tonight. Hopefully you've noticed this report on your seats as well. It's hot off the presses. This is a copy of the Commission's first major report on renewable energy, and it was just released just over a week ago. So it's called The Critical Decade, Generating a Renewable Australia. The report finds that while Australia is doing well in this area, it could be doing much more, and there's huge potential for renewable energy, which is currently underutilised. So enjoy flipping through that at your leisure, perhaps a bit of light bedtime reading tonight once you get home. But another very important aspect of this evening that the Commissioners would also like you to particularly note are the feedback forms on your seats. Can you please ensure that you fill those in and leave them on your seats as well, because they really do provide valuable feedback for them on how to better run these forums. So the whole aim of tonight is to begin a conversation. The Commissioners really want to emphasise that they're here to listen, as well as to share some of their latest findings and knowledge and experiences. So to start with tonight, we'll hear some of that latest information from the Commissioners and also the impacts that a changing climate will have for South Australia, as well as some of their thoughts on the way forward. After that, and for the majority of this evening, we open the floor up to you and we give you the opportunity to ask questions of the Commissioners. So may I introduce Professor Tim Flannery, the Chief Climate Commissioner. Professor Tim Flannery is one of Australia's leading writers on climate change and an internationally acclaimed scientist, explorer and conservationist. Many of you will remember his time as the Director of the South Australian Museum and as Professor at the University of Adelaide. He's now the Panasonic Chair in Environmental Sustainability at Macquarie University. Professor Flannery was named Australian of the Year in 2007. Please welcome Professor Tim Flannery.
Thank you for that, Nance, and thank you for moderating for us this evening. And welcome everybody to this, our 19th Community Forum as Climate Commissioners. The last 18 months has gone by very quickly for us all. I'll just introduce my fellow commissioners on the stage here. We have Professor Will Steffen, who is a climate scientist, one of the world's most eminent climate scientists. If you have any questions about the Earth system and global warming and so forth, he's the man to turn to. We have Professor Leslie Hughes next to him, who is another climate scientist with a great deal of expertise in the area of biodiversity impacts of climate change, but also in adaptation overall. So again, questions in that area, I'm sure Leslie would welcome. We have Jerry Houston next, and we have all of the commissioners here this evening, which is not that common, so you're lucky. Jerry's really our business voice. Jerry has had 30 years in the oil and gas business, and ending his career there as the CEO of BP Australasia, and really has a great deal of expertise in the way business approaches this climate challenge, which is important. We then have Professor Veena Sahajwalla from the University of New South Wales, who is an engineer, I think.
Yep, that's right.
Yeah. And Veena has had a long history of working with businesses across the spectrum, but particularly in the steel sector, in terms of efficiency, using waste, recycling, and addressing climate change. And we have at the very end Mr. Roger Beale, who has spent longer than he'd probably like to admit, representing Australia at various meetings right back to the very beginning of the international negotiations in the climate area. I think I need say no more than that Roger really is of great international standing as an economist in this area. He's off to China next week to advise Wen Jiabao and the Chinese government on aspects of climate change, which he does regularly. He's on the committee that does that. So that's the Commission. Our job is pretty simple. It's really just to engage in a discussion with people like you, members of the Australian community, about all aspects of climate change, whether it be the science, the economics, business impacts, or what's happening internationally. There's a couple of things we don't do. We don't advise government, so we have no role in that area. We're independent of government, and we don't comment, we don't tell you what to think about government policy. Basically, we can describe policy and so forth, but we want to remain apolitical, because one of the great difficulties of addressing climate change is the highly politicised nature that the debate has descended into. We think that there is really a role for clear, authoritative information so that people can make up their own minds, and that's what we're here to provide. Having said that, we do have a small slide presentation that we're going to show you, but really this evening is your evening. We're going to leave the lion's share of the time for your questions and a dialogue to ask whatever you want. But to kick off our brief presentation, Will Stephan will come and talk about climate science, the latest climate science.
Well, thank you very much, Tim. We always find it useful to start with a little background on the science, and I know that many of you are already familiar with some of this, so I'll go through the very basics rather smartly, but then I'll get on to some of the newer science that is giving us some insights as to how the climate system is really changing. So let's kick right off with what most people think as the most important indicator of climate change. That's the temperature of the atmosphere near the Earth's surface. It goes all the way back to 1880 when we first had good measurements globally, and you can see that there's a lot of variability from year to year. Not every year is warmer or colder than the one before it. That's what's called natural variability. But from about 1960 or 1970, there's a very clear upwards trend which continues, and we'll get on to why that is so in a minute. But scientists don't stop with air temperature. It's very important for us because we feel it. We're walking on the surface. But actually, the most important part of the Earth system in terms of climate is the ocean. And that's what's happening to the temperature of the ocean. Now, if you've done first-year physics, you'll realize that the heat capacity, the capacity to absorb heat, is much bigger for water than it is for air. So about 90% of the extra heat at the Earth's surface is actually going into the ocean. It's not going into the air. So for scientists, this is a smoking gun. Now, we've had good measurements since about 1960 of what's going on in the ocean. And again, you see from about 1970 onwards, there's a very clear upwards trend. That's absolutely undeniable. Why is this so? Well, we know a lot about natural variability, and this does not look like natural variability. And we also know the physics of how energy is absorbed and released by the Earth's surface. It's called the greenhouse effect, and you would have heard of that. The way it works is the incoming sunlight passes through the atmosphere unimpeded, unless, of course, there are some clouds that bounce it back. But when it hits the Earth's surface, it warms the Earth's surface. In fact, it makes it habitable. To keep the energy balanced, the Earth must give energy back out to space, or else it would continually warm up and burn up. It does that not by light, but by heat. So it's a different wavelength of energy. This belt of gases called greenhouse gases, and CO2, carbon dioxide, is the most important of them, of the long-lived ones, has the property of allowing the light to come through unimpeded, but absorbing some of the heat coming back. So that traps heat around the surface of the Earth and keeps it warmer than it otherwise would be, which is a good thing, or else life wouldn't exist. The natural greenhouse effect raises the surface temperature by 33 degrees Celsius. So here's the issue. When nature puts greenhouse gases in the atmosphere, the Earth warms. So when humans do it, the physics is exactly the same. The Earth will warm. This is an example I'm going to show you of how scientists actually test that understanding. I'll show you a graph from 1900 to 2000, the last century. Now, we know a lot about natural variability. Many of you may have heard, well, the Earth always warms and cools. Why isn't this natural variability? Well, it does always warm and cool, and that purple line shows what it should have done last century. It's not exactly flat. It goes up a bit around 1950, goes down again. Natural variability. Then we can put in our models the extra greenhouse gases that we have emitted, mainly by burning fossil fuels. And when we do that, that's what it looks like. You really can't differentiate again until about 1970. And then you see the climate models, which are generating these wedges, show that temperatures should rise. Now, this was last century, so we have measurements, and that's what the measurements show, the black line. So the measurements fit very well, particularly the second half of the century, only when we include the extra greenhouse gases that humans have emitted. Now, I could go on and on for hours telling you all sorts of other evidence that's all consistent, that the primary cause of that warming are the extra greenhouse gases that we've emitted. But something's really interesting happening, at least up in the far north part, and you may have heard of this very recently. If you look at that right-hand panel, it might be a little bit hard to see. That white blob is the sea ice floating over the Arctic Ocean. You might just be able to see a red line. It's very hard to see around the outside. That shows the normal extent of that sea ice in the summertime. It's shrunk to about half. Now, there's a couple of interesting things happening. Once that sea ice shrinks, you can see that the ocean water underneath it is much darker. That absorbs more sunlight. It warms the northern high latitudes more, which leads to more loss of ice, which leads to even more warming. It's what we call a reinforcing feedback. Now, we think that we've gone beyond the point of no return, the tipping point on this system. And no matter what we do now, this is going to become ice-free within a couple of decades. Now, here's another interesting facet. Why is that important? Look at the land circling that. A lot of that land in Siberia and in Canada and Alaska is frozen soil, and it contains an enormous amount of carbon. It contains twice as much carbon as is in the atmosphere. Some of that's starting to bubble up as the permafrost, the frozen soil melts. In fact, we can even light it and have flames coming up. It's methane, primarily, some CO2. The problem with the warming there is once it reaches a certain point, that will again be self-reinforcing and will be committed to much more climate change that we cannot stop. This is one of the pieces of evidence why scientists say 2 degrees should be the limit. Beyond that, we're in dangerous territory. And a little bit later, Leslie's going to show you a slide showing that 2-degree guardrail and where we are against that and where we might be going. So this is a good example of the complexities of science that are just coming to light as we see how the Earth is responding to our extra greenhouse gases. The other one, and I want to finish on this one, is actually more important directly for us humans because it affects us directly. This is what climate scientists call extreme events. You would know them as heat waves, bushfires, floods, the unusual weather events that actually affect us. Now, this little graph here, this gray line, shows a distribution of temperatures. For example, if you were in Adelaide, say in January, the average temperature might be 29 or 30. It's pretty hot in January in Adelaide. So that might be the peak of that gray curve. But not every day is 29 or 30. Some are cooler, like today is probably lower than average for Adelaide in early December, and some are hotter. And that gives you that distribution. So you get some very cold days, some very hot days, but most of them cluster around the average. Now here's the point about small changes in average temperature. You shift that whole curve, and that's what the red curve shows. So you still have cold days and hot days and an average, but the new climate looks really different. And it looks different at the ends. That's what's so important. You only had a little bit of hot weather under the gray, but that becomes much more common under the red. And you get new temperatures over here, way on the right of the red line that you never had before. What's an example? Melbourne, 2009, where they broke the record, not by a fraction of a degree, but by 2 or 3 degrees Celsius. The chances of that happening without underlying climate change are almost zero. So this is what it really means for us in terms of impacts and consequences. We're going to try to bring this home to you now a little bit more clearly, and Leslie's going to tell you about what might be in store for South Australia.
Thank you. Thanks, Will. Okay, well, that's the sort of the global general picture. Let's talk about something that's a little bit closer to home. This is the temperature record for South Australia. If you look at that line in the middle, that's the average temperature over the period going back to the beginning of last century up until now. And all those purpley bars are all of the years where we had a below average temperature. And all the red bars are the years where we've had an above average temperature here in South Australia. So you can see that as we've gone through that century, there's more and more years of above average temperature. And in fact, the average temperatures in South Australia have gone up about a degree overall since about the 1950s. Rainfall has also been changing. It's been changing all over Australia. This map shows the rainfall trends going back to 1970. And all of the green areas on the map are the parts of Australia that have been getting wetter, and the brown areas are the parts that have been getting drier. And as you can see, South Australia, like most of the eastern part of the country and the southwest, has been getting considerably drier over that period. In fact, during the last drought that we had, which lasted from 1997 to 2009, the River Murray, which of course is all dear to your hearts, the flow in the Murray was about 50% below the average over the longer period. So these sorts of things that Will has been talking about, of course, lead to more extreme events. Will has talked about some of them, but there are other sorts of events as well. Even though that we're possibly continuing on in a drying trend, most of the climate models indicate that when we do get rain, it will come in more intense bursts. And of course, that's when we get flooding. This, I believe, is Narracourt during the last set of floods. So just because we're in a drying trend, we still get extremely heavy downpours from time to time, which cause damage. There is an increased risk of bushfires, of course, especially if we get drier as well as hotter. And, of course, the citizens of Adelaide certainly know with the hills area what the impacts of those fires can be. And the general projections are for more extreme hot weather and extreme fire weather in southeast Australia. And then, of course, there's extreme heat and drought. I've mentioned the drought in the River Murray already. Currently, Adelaide gets about 17 days a year, on average, over 35 degrees. The projections are by 2030, for 23 days over 35 degrees, and by 2070 for about 36 days over 35 degrees. Now, of course, it's not just about feeling uncomfortable. Hot weather actually kills people. So during the period around the Black Saturday bushfire period in southeast Australia, about twice as many people died from heat stress, mostly elderly people, as died in the bushfires. And during January and February 2009, Adelaide got to 45.7 degrees. I'm sure many of you will remember that. And of course, our water security, I've already mentioned the Murray, and our agriculture. Wine grapes, for example, are worth $1.7 billion a year to the South Australian economy. Wine grapes have actually been ripening earlier. There's lots of plants and animals whose life cycles are changing. And of course, wine, where it relies on irrigation, will be at risk with a drying climate. So everyday life in South Australia is affected by climate. But I'd like to talk a little bit about long term, and really this illustrates why I and the rest of the commissioners are up on this stage. This, firstly, is the temperature record of what we've had and also of what we might have in the future. So if we look at that little wiggly black line on my side of the graph there, that's the temperature that we've had so far. Will showed you a bigger picture of that, going back to 1900. And what this is showing is kind of the two extremes of our potential future going out to the end of this century. The blue future is if we can make very deep cuts in our emissions, we may be able to keep global warming to 2 degrees or less than it was above pre-industrial levels. So that's one future. The red area of that graph is if we keep doing what we call business as usual. So if we keep emitting and accelerating our emissions going forward, that is the range of future temperature possibilities. The World Bank, for example, released a report about 10 days ago that indicated that 4 degrees of warming was much more likely than 2 degrees based on our current trajectory. Now, I realise that just looking, people like Will and I who are scientists, we live by graphs, we love graphs. But graphs don't mean an awful lot to absolutely everybody, so I want to make this graph a very personal one. So firstly, I'll put me on that graph. I was born in the 1960s, and I'm hoping to live till I'm about 85, maybe even more. So that's my lifespan there, and I've drawn that bar at the average temperature that I will experience over my lifespan. Now, I've got 2 teenage kids born in the 1990s, so let me put their 85-year lifespan on the graph at the temperature on average that they will experience over their lifetime if we fail to curb emissions. Now, I don't have grandchildren yet, but if my kids have kids when they're about 30, then my grandkids will live through to next century, and that's the line of the temperature that they will potentially experience over their lifespan. And that's a pretty scary prospect, looking forward to the future of my family. So what we need to do is act very, very decisively to bring that line down for the sake of my kids and your kids and all of our grandchildren. So with that, I'd like to hand back to Tim.
Thank you. Thanks, Leslie. I just want to talk briefly about action in Australia and how it corresponds to what's happening in other nations. We've had now 3 or 4 years of pretty active international negotiation trying to broker a global treaty and to try to get a series of arrangements in place below that. As of now, there's about 90 nations around the world which have climate action plans. They cover 93% of global economic activity, so it's quite a broad range already. Unfortunately, the cuts that are pledged under those action plans are not nearly enough to achieve what we need, which is to have the emissions reduced. If you look at Australia's pledges and actions compared with those of other countries, you see that we're in about the middle of the pack. We are the 15th largest emitter of greenhouse gases in the world overall, and a very, very high per capita emitter. We're the highest developed major economy anyway in the world. The 2 big emitters overall are China and the USA. Both of them are taking significant action on this issue. In the case of the USA, emissions are actually dropping, and they look like they're going to be on track to achieve their target of a 17% reduction in emissions below 2005 levels by the end of this decade. The Chinese have made enormous strides in terms of renewable energy technology, and I'll talk about that a little bit in a moment. But their emissions are going to grow for some time yet, simply because they just don't have enough energy to run the economy for 1.3 billion people. But they are making enormous strides, and their pledges are a very, very significant part of global action. So the world is moving, not fast enough. Australia's actions are about in the middle of the pack. Unlike South Australia, and I want to talk a little bit about this state because you have done incredible things here, and I can tell you if the world was doing as well as South Australia, we'd be well down the road to having this problem solved. I lived in South Australia for 7 years. I left in 2006. At the time I left, wind energy in this state was about 1% of overall energy that was used. This year, it's 26%. Can you imagine that? That the speed of deployment has been fantastic. Major, major contribution to Australia's combating of climate change. And you're building a major new export industry here in this state. The wind sector is undergoing great changes at the moment. In fact, next year, a new wind technology is going to be deployed in South Australia. First time ever in this country, and one of the very first times in the world. It's called gearless wind turbines. They're a new turbine technology. They'll be up at Snowtown. It'll be 280 megawatt wind farm. Very, very efficient, very low maintenance requirements. a very significant step forward. So you've done fabulously well here in wind. And of course you've got a world-class wind resource, and you've had, through successive governments, pretty good, not perfect, but pretty good regulatory environment to allow the industry to grow. Solar is the other industry you're doing very well with here. I remember when I left South Australia, flying out to go to Sydney, where I was taking up another job, and looking down at the rooftops of Adelaide and seeing virtually no solar panels. That was 7 years ago. Today, 1 in 5 rooftops in South Australia have solar panels on them. It's a huge incremental increase. And that's been made possible by dramatic changes in the cost of solar energy. Over the last 4 years, the cost of producing solar panels has declined 75%. Can you think of anything else that you buy whose cost has declined by 75% in the last 4 years? Cost of production. And in China, one of the big manufacturers called Suntech, I was looking at their figures, they project that this year costs are going to decline another 30%. And costs of installations are declining. People are using Google Earth now rather than sending a bloke on a ladder around to your house to put on the panels, so they can do it all cheaper. Cost of inverters are dropping, and solar is becoming more and more cost competitive. What these technologies are doing really to the energy sector is very much like what's happening in the media sector. You know, there used to be a few big generators of news and a lot of small consumers, just like the energy sector, a few big generators of electricity and lots of small consumers. Well, now, courtesy of the net, there's lots of producers of news with blogs and so forth, and a lot of consumers of news, small ones, and the big players are starting to shrink. Same's true for energy. Solar panels, community-owned wind farms and so forth are leading to many, many small generators of electricity and a whole lot of small consumers. So we're going to see dramatic changes in that sector in years to come. So what's the next chapter in the climate story for South Australia? Really, really difficult to pick the winners in the energy sector. I know that to my great cost. While I lived here, I bought probably an inordinately large number of shares in one of the geothermal companies. And I'm sure I'll be rewarded in heaven for that, but perhaps not for some time. So, you know, we can all make mistakes in that area. But one thing that is becoming clear is that solar thermal technologies are going to play some sort of role in future energy mix. They're already being deployed in Spain and the USA. This is the array on the left here. You can see a solar thermal plant. The great advantage they bring is that they allow you to store energy from the sun, and so they give you a continuous power supply. There is the option in South Australia, I know it's being very actively debated now by various groups, of installing Australia's first solar thermal plant up towards Port Augusta. So, well, whether it'll happen or not is still an open question, but there is community support and action for that, which is great. And I guess if South Australia goes about this with some conviction and some dedication, it's possible in the future that solar thermal will be the next wind story for this state. You'll lead the nation, again, possibly bring a very important technology online and hopefully reap the benefits of that. Transport also, lots of changes in transport from electric vehicles, electric cars, through to light rail and so forth. And as that comes in, that is going to lead to changes yet again in the energy sector and the way we produce, consume and store electricity. You know, if we continue on as we are globally for another 5 years, out to 2017, we will have already built all of the fossil fuel plants that are needed to drive us over the safety barrier of 2 degrees of warming. So something has to change very quickly. And a lot of that change, sure, it's going to happen at the national level and industrial level, but there's a lot of things that communities need to do to make sure that we drive the uptake of clean energy as fast nationally and as fast in future as South Australia has done over the last 5 or 6 years. We can do that by becoming informed, by making some practical changes at home. Have a look around, have a look at your energy bills, do the equation, see if solar works for you. Work with local community groups to reduce emissions. And there's some fabulous groups, including the Australian Youth Climate Coalition, who are active in Australia doing these sort of amazing events that help people get more energy efficient and be able to afford clean energy technologies. And be a leader in the area. Talk to your family and friends and the wider community about what you hear this evening, about the need for action. And hopefully we'll be able to move forward faster than we otherwise would have. That's it for me. I'm going to hand over to Veena now, who's going to say a little bit, I think, about this slide and a few other things. Thank you.
Thanks, Tim. It's all right, I can stay here. I guess I just wanted to maybe pick up on the points that Tim has made. I mean, all of us are here today because we actually want to see some action happening. We want to be able to do our bit. So as individuals, there's that passion to actually be ambassadors for change. And I think that's essentially the point why we're here. So I think the best thing you can do is picking up on some of the information that you hear tonight is to go out and talk to your family and friends, whether it's about making a change within your own homes or whether it's in your communities or even in your local business areas. It's really about being ambassadors for action. And I think I just wanted to make that quick point. And clearly there's a lot of information that's available up on the websites that actually give you some ideas around what can be done right at the local community level all the way up into workplaces. Lots of strategies and solutions to implement ideas from small things that you can do at home to bigger community-based changes. So I just wanted to leave it at that. Thank you very much.
Thank you, Commissioners. Well, now's the time that we hand it back to you and give you the opportunity to ask your questions. So again, we ask that you please keep your questions short and focused and refrain from making long statements. Thank you. We ask that your questions are brief so that we can fit in as many questions and answers as possible. There will be mic runners who will pass you a microphone. Please put the microphone close to your mouth so that we can hear you, a bit like karaoke. Don't be shy. Put that mic right up to your mouth. And please stand and tell us your name and where you are from so that we can identify you. That would be great. And a reminder tonight that all the vision will be uploaded to the website, the climatecommission.gov.au website, so you'll be asked to sign a release form after you've asked your question. So please, at this point, we ask everyone to be respectful of all opinions and we hand over to you. Who would like to ask the first question tonight?
Look, I'm sorry to harp on this, but I'd really like to know what's happening with the hot rocks technology. Is it stalled because of lack of funding or lack of political will? But what the heck is going on? I'd really like to know.
Look, I can only tell you what I learned from, my holdings in one of those companies, ever shrinking holdings. I think what we've found with these technologies is that they appear simple on the surface, but there are a whole series of technical challenges that have to be met in order to release the potential of that energy source. In earlier years, there was a thought we could develop these quite quickly and bring them to scale quickly. What we've found is, in fact, it's much more difficult than that. And the head of geodynamics, who I bought shares in, his view is basically you've got to deal with this resource as you would an oil or a gas resource, which is to prove up the scale of the resource first and the usability of it. So how big is the usable resource? And then you can start to do things, because then you have potential money in the bank, to do that. So what all of that means really is that the development of these technologies is going to take longer than we thought. It'll probably be another decade or two, somewhere in that line, before they're really at scale, really large scale. And of course, there's lots of competition out there. We've seen the cost reductions in solar and wind and so forth. So there's a lot of competition in the energy sector. I'm not selling my shares. I'll hold on to them. Perhaps the grandchildren will benefit, even though we're leaving a warmer climate for them. But that's the best summary I can give you. I say I'm not an expert, but perhaps others will have something to say.
And so you had a question with your jumper, yes. Can you give your name and where you're from firstly? Thank you.
My name's John Ettridge. I'm an Adelaide inventor. I have several companies which are about to go out of business, but that's another story. What I wanted to know is, with the graphs that you had there, did you take in allowance the fact that China and India are coming on board now as far as pollutants? I mean, back at the last energy crunch, China and India weren't even considered. Today, the graph would go straight through the roof if you actually did take that into account. Also, I noticed in today's paper that there's 100,000 cars sold in Australia last month. Very few of them were made in Australia. So are we just exporting our jobs and the pollution to overseas?
Thank you.
Yeah, look, I'll make a comment on that. The answer to your first part of your question is yes, all global emissions are taken into account in those graphs, including China's and India's, Brazil's. Yes. And the second part of your question is one of the reasons we get this pretty right is that it's a global total. And we do account for the fact that there is a shift in manufacturing from the wealthy countries to the emerging economies. Now, when you unpack what the pretty frightening emission curves look like, they actually give you a bit more cause for hope. And I'm going to turn it over to Roger in just a moment to talk about China. But let me just say scientifically what's happening is, and you may have seen this in the news on Monday when the latest emission data were released. We're tracking on that red wedge that Leslie showed, going up pretty high. But when you look at the developed countries, the wealthy countries, as Tim said, the US is already going down. Part of it's because they have offloaded a lot of their manufacturing to China. Part of it is they're actually switching energy sources. Europe is already well going down. I think Australia's peaked. We're headed down too. That's actually what we scientists think needs to happen to hit that 2-degree target. The action is now shifting to those emerging economies who are growing very strongly. The other thing I will say, if you looked closely at Leslie's graph, the big, scary orange wedge and the safe blue wedge really didn't start separating until between 2020 and 2030. What that tells us is that we in the developed countries are getting our emissions down as we need to be. They need to now come down faster. Also, we need to make the right investment decisions this decade to make sure we start moving on to that blue curve. And that's particularly true for the emerging economies. And for that, I'm going to turn over to Roger. He knows a lot more than I do about China and what's happening.
Well, if we just take China as an example, it is moving very strongly on renewables and on nuclear. So it's the world number one producer across a range and user across a range of the major renewable technologies. And that's in that report that's available, the latest one on renewable energy. However, having said that, China's trying to get its renewables up to about 11% of its total power supply, but it still has to drive energy for its people because they have an expectation of better living standards. And in fact, something like 80% of the growth in emissions that's occurred, and it's occurring at about 3% per annum, is coming from China at the moment. Now, the Chinese are hoping that they will peak their emissions in about 2020 or in the decade beginning in 2020 and start to move south, in other words, to reduce them again. I'll be saying to them next week when I'm speaking in Beijing at the Advisory Council that, frankly, if I was an investor and I was looking at fossil fuel power plants and associated investments at the moment, I would be thinking that these will only have an economic lifetime, if they're going to achieve their greenhouse targets, that is much shorter than they would otherwise have expected. So therefore they better try and build them in a way that's either carbon capture and sequestration ready, it's got to be as efficient as possible, or it's got to be in smaller units so that they can progressively replace them. But it's a transition, and it's a transition that's going to happen all around the world as we move from a fundamentally fossil fuel-driven power system to one that's fundamentally renewable-driven. And it's a difficult transition because you have to maintain the integrity of the grid at the same time as you move from the equivalent of the old, copper-wired telephony system to mobile phones. You've got to keep everything working. So it's a really hard and difficult ask. But the one thing I get in China is a total commitment to the science. I don't have too many people saying, well, we think this is all crap. They know what the problem is, and they know it's a big problem for them.
Thank you for that, Roger. And I should mention too, if you do have follow-up questions, the commissioners will be staying tonight. Please come out and have a cuppa with them. So there will be an opportunity to ask more questions. And we do ask if you can keep it to one question and ask your follow-up questions afterwards. Sir, can we go to you with the moustache? Thank you.
Peter McFarlane from down Holfast Bay. Given the introduction that the current 0.5 degree shift in temperature is apparently a tipping point for the loss of the polar ice caps, how does a 2 degree target save us from rising sea levels?
Yeah, okay. The rise we've had to the moment has been about 0.8 degrees on a global average, okay? And it's been higher up in the Arctic because the warming is higher in the northern high latitudes. It doesn't save us from sea level rise. In fact, we've already seen about 20 centimetres of sea level rise over the last century, and the rate is now about 3 millimetres per year, so the rate has actually increased. And because of that big inertia in both the ice sheets on the poles and the oceans, the sea will rise for centuries into the future. The question is whether it's going to equilibrate out at a couple of meters more than it is today, or whether it's going to go up tens of meters. And that's that critical difference between those two curves that Leslie showed you. Our best estimate for people to plan on for 2100 is between half a meter and a meter. It'll vary because it varies regionally around Australia. Much higher in the north, a little bit less in the south. That's a long time frame. We renew a lot of infrastructure between now and then. We can plan to put our new infrastructure in safer places. We can harden some places around valuable infrastructure. A good example perhaps could be Botany Bay and Sydney Airport. Others, like Brisbane Airport, are much more difficult to deal with. The point is, we're committed to a significant amount of sea level rise, but it's going to occur on a human time frame at a fairly slow rate. We have time to adapt, and that's where adaptation becomes really important.
And could I just add to that, just for South Australia, so as Will said, the global average is about 3.3 millimetres a year. South Australia, it's about 4.3, so South Australia, it's rising a little bit higher than the global average. And with a metre of sea level rise by the end of this century, that represents on present values about $45 billion worth of infrastructure in South Australia at risk.
Yes, the lady there with her hand up with the black. Thank you, ma'am. Black shirt. Thanks.
Hello, my name's Robin from the Climate Emergency Action Network here in Adelaide, a grassroots community group. Tim was speaking about the great things South Australia is doing in terms of wind and solar, and I agree, and solar thermal for Port Augusta is really exciting and a campaign I've been helping with, along with lots of other people. But at the same time, our government is supporting Santos to commercially produce shale gas up in the Cooper Basin. That started a couple of months ago.
So what's your question, sorry?
Well, my question is, does the panel, anyone on the panel, have information about the fugitive methane emissions from that kind of technology and how that might counteract the good things we're doing in this state?
I'll have a try to answer that. Will may have something to say as well. I think that we're in a position in Australia where we haven't got a good handle at all on fugitive emissions. I haven't seen any data that I could call definitive in that way. And the way that we've gone about developing the industry has meant that we really do have a deficiency of information. So there's no requirement, for example, in some states to collect baseline data on what greenhouse gas concentrations are like before development versus post. So there's things we can do that are pretty common sense to get that information, but so far I think we really do lack the basic data we need.
Yeah, I think that's right. I've seen no credible peer-reviewed literature on what those emissions actually are, and I think we pretty smartly need to get that data before we can make sensible decisions.
Colleagues, would it be right to say that it's likely to vary from place to place?
Oh, it'll be highly variable.
area-specific examination of what the baseline is and then what the changes are.
Yeah, and that's important information you need to have before you decide whether you develop it.
And it is very early days for shale gas in Australia. Like this is a proposition to test it practically and economically, and and it is quite different potentially from the experience they've had in the US.
Yes, sir, down the front with the glasses. Thank you.
Thank you. My name is Ed Durand, and I'm happy to be in this hall because this is where I finished my high school, and I haven't been in this room since I left. And I did have to visit the principal's office, that little round one out the front.
And what's your question, sir?
I noted that Professor Stefan talked about CO2 being the major greenhouse gas, and he did say that the graphs showing the rising temperatures are from models. So I have two quick questions.
Just one, if you could, please. We are trying to limit everyone to one, but yes.
Okay, I'll
continue.
Skip the first one and assume the answer is that...
Thank you.
I'll skip the first question and say what the answer is. H2O is a very, very much stronger greenhouse gas than is CO2. I'll accept that as a yes. So my second question needs a little preface of the high school science that I learnt right here.
Very briefly, yes.
Very quick. It's a fact that CO2 is gaseous at all temperatures and pressures that exist in the atmosphere. It cannot, therefore, form clouds of liquid droplets and ice like H2O. Likewise, it does not have the ability, like water, to evaporate from the oceans, cool the surface, and convey by convection massive amounts of energy into the troposphere where the radiative balance of the Earth is established.
Mm-hmm. And your question, sir?
I'll skip the next bit. Why would the climate models at the University of East Anglia and the Goddard Institute of Space Studies insert various levels of strong positive feedback into their models on the unvalidated assumption that a warmer temperature means more water vapour in the atmosphere, and water, because it's a greenhouse gas, means that that is a long-term positive warming feedback, when short-term water feedbacks are clearly negative. And everyone in this room has experienced those negative feedbacks. When the clouds pass over the sun on a hot day, you suddenly feel cool. And in a cold night, if it's cloudy, you feel warmer.
So that's your question?
These are negative feedbacks.
Right. We might throw to our scientific expert.
My question is, why do the modelers insert huge amounts of positive feedbacks in their model when there's no valid reason for doing so?
Thank you.
First of all, just a couple of corrections. One is I said CO2 is the most important long-lived greenhouse gas for exactly that reason. Second, the graphs I showed you were observations. The first graph I showed you was not model, was an observation. The graph with the two wedges and then the black line, the two wedges, the purple and the blue, were model simulations. The black line were observations, and the black line fit perfectly when you included CO2 and its feedbacks. Now, if you double CO2 in the atmosphere, you get about a 1 degree Celsius warming. That is amplified by the water vapor feedback. A warmer world evaporates more water. There's more water vapor in the atmosphere, and as the gentleman said, that is also a greenhouse gas. That leads to about another degree warming. Now, is this a mythical feedback? No. We can actually measure the amount of water vapor, and just as physics suggests, it has increased in response to the greenhouse warming. Clouds are trickier, and that's where the climate models don't always agree. But the consensus is that when you take the various types of clouds, some of which indeed cool the climate, some of which warm the climate, when you take those into account, you get approximately another degree of positive feedback, in other words, reinforcing feedback. Bottom line, when you look at the whole climate system, for a doubling of CO2, you get about 3 degrees of warming. That's robust. If you look at the past, when we've seen past changes in CO2 and past changes in temperature, the only way you get the answer right is if you get that sensitivity at about 3 degrees. There's an enormous amount of science that supports that.
Could I please direct our next mic runner to the man in the white T-shirt with the camera? Yep. Thank you very much.
Hi. Oh, that's louder than I thought.
Another person with a loud voice. That's good.
I'm one of the activists who walked from Port Augusta to Adelaide in order to promote solar thermal here in South Australia. And one of my questions is around the Beyond Zero emissions plan to convert Australia to 100% renewable energy. I'm going to assume that that's a good thing. How can we help as people in South Australia to get that to happen? How can we get to 100% renewable energy?
Okay. Veena, would this be your area of expertise?
Yeah, in fact, I was going to say, I mean, it kind of follows on a little bit from what we've been talking about. If you're looking at being ambassadors for action, you can actually look at action at various levels, like we said. I mean, you've got individuals in their households, but if you're looking at sort of making big step changes in terms of what you can actually achieve at the community level, you can really start to pull together how, as a community, we can actually cause action to happen, which is, clearly from your nods, you're sort of agreeing that that's the way forward. So I think the best way to address that is by looking at businesses that operate at the community level. And I think the simplest example to look at is something like shopping centers, where you've got massive consumption of energy. The shopping centers as an example of community-based sort of energy consumers, but also will respond to what community will demand. So if community members are, in fact, being ambassadors for that action which says we want more renewable energy to be implemented, I'm pretty sure that shopping centers, and I keep using that as an example because that's where there's a mega business that's operating and people can actually see the change. So I'll give you an example. In fact, Leslie and I were at Willoughby City Council as one example of what was happening there in that local area. And the local shopping centre actually had on its rooftop a massive sort of installation of solar farm. And I think that's an example of how, as consumers, we actually can have a massive say in terms of how local businesses make choices around energy solutions. So I think that's really a good way to, in fact, ensure that the change will happen because the solutions exist. It's about the action for implementation.
I think it's also worth noting this is a global issue, and to crack it, you need the involvement of business, and the way business will look at it is saying, we want to try and find the lowest cost way, and as a community, we want to try and find the lowest cost way. So that's going to mean a multifaceted approach. There's going to be current solutions today, and as we go over the next 40 odd years, there'll be other solutions that develop. And from the business community's point of view, having a price on carbon and then driving the innovation and the incentives to business to actually make it happen in the lowest cost way is going to be the way in which it's going to be most acceptable for the community. So we need to be careful that we don't just think there's a silver bullet out there and we can rush down one burrow and solve it overnight, because that's not likely to be the lowest cost solution. But actually harvesting the innovation and business expertise to actually drive the solution globally on a reasonably consistent basis is ultimately going to be the solution.
And please remember, don't forget to come and have a cup of tea afterwards with your follow-up questions. The commissioners really do want to follow that up with you. So, yes, now our next question. Perhaps ma'am here with the white shirt. Thank you. Yes, thank you.
From Adelaide, Aberfoyle Park. I'm wanting to know, is it a fact that the Climate Commission may disappear if there's a change of government? And have I just heard that incorrectly or not?
No, that's the case. The Abbott government has said that they'll abolish us as one of the first orders of business. So. Anyways, so.
That's pretty quick answer. And perhaps up the back, please, to this lady here with the glasses and the blue shirt. Thank you.
Hi, my name's Katya. I'm part of the Australian Youth Climate Coalition. I'd just like to ask, at a 4-degree temperature rise model, taking into account the sea level rise and food scarcity and freshwater scarcity, how many people will that sort of world support?
They're vastly different estimates of what that might be, all the way up to 7 or 8 billion, down to 1 billion. The one thing that's clear is it's a very hard world to live in. It won't be like the world we know today. And there are various estimates of how much incomes, health, lifespans, and numbers of people might drop in that sort of world. As a scientist, I would just sum all that up by saying it's a world you would never, ever want to wish on your grandchildren.
I'd just like to make a point from a recent experience, actually. It's not just a 4-degree world where people are struggling. I've just got back from, I work for a charity, and when you go out and see these rural villages, they get it. They're already saying they've seen the results of climate change. The rains are coming at different times and different intensities. They can't grow the crops that they used to with the certainty that they had, and they understand it. So these are people who are living on less than $1 a day, saying that they've already started to see changes that are different to the memory of their generations. So then you translate that into what would you see as a 4-degree world, and one thing's for sure: it's the poor of the world that are going to suffer more than the rich, and that's going to be one of the tragedies.
And if I could just add to that, we were talking about sea level before, and the projections for about a metre perhaps by the end of this century. There's already right now 100 million people living around the world within a metre of sea level rise right now. So, and they're in the places like the Bangladeshi deltas and things like that. So I think I agree with Will, we can't imagine a 4-degree world, but it's not something we want to experience.
Yes, can we please go to this lady here with long hair? Thank you. There's a lot of those. Sorry, I just can't quite see your stripy shirt. There we are. Thank you.
Hi, my name's Pippa Williams. I just finished a degree in sustainable energy engineering. So my question is, we've seen, there are a lot of opportunities for new renewable and other sustainable energy options, but I'm seeing a really scary growth rate still in fossil fuel development and investment, which is really hard for people to kind of get out of that cycle, people whose livelihoods depend on that. Is this something that we kind of politically are going to be able to overcome quickly enough to look after our grandchildren?
Well, that's a great question. Look, I'll have a brief go and then I think hand over to some others who might have something to say. Will, Stefan and I were discussing this earlier on, and Will made the point that we can only burn about 30% of known conventional fossil fuel resources and still stay within the 2-degree guardrail. So that means we're going to have to leave a lot of coal in the ground and perhaps some oil and natural gas. So the political feasibility of that is, it's not easy. But just from a personal perspective, we've seen in other instances other minerals left in the ground. So asbestos used to be a major industry in Western Australia. It was shown to be dangerous to individual human health, and those mines were shut down, and remediative action taken and substitutes found. So I do have some hope, I suppose, that we will see that some of these fossil fuels are dangerous to the health of the planet as a whole if we burn them all. And we'll take action. But the kind of action that's needed, I'm not sure. I mean, you might...
Yeah, I think it's a very good point, but I think some of the rhetoric we see in Australia is so let's shut down our export coal mines, for example. That's not dealing with the issue. This is a global problem, and there is a surfeit of coal globally. So the problem wouldn't go away. You'd just be sourcing the coal. The Chinas would be sourcing the coal from somewhere else. So the critical thing is breaking this link between increases in prosperity and wealth to energy, breaking that link so that the Chinas and the Indias of this world can develop a better standard of living without the sort of dependency that we grew up with on energy, and so reducing the demand for the use of coal will drive it, not any political move in producer countries like Australia, because there's plenty of places like Indonesia and Mongolia that could fit it. So it's not a simple solution. Ultimately, we have to actually drive the demand for fossil energy down.
I think also it comes down to having innovative solutions. I mean, it was mentioned earlier that if you're going to have innovative solutions that are driving you away from our dependence on coal-based solutions to other more creative strategies, I think that's the way forward as well. So, I can give you an example from our own work, for instance, in steel production, which certainly I'm sure you're all familiar. There is steel production happening right here in South Australia. It uses enormous quantities of energy. So you might say, well, okay, one way to address that is to say, let's reduce the amount of coal that's required to make steel. You're not going to stop making steel. But what you can do is get away from that dependence on coal, but look at other more sustainable solutions. And that's really the clever way of approaching these types of strategies, is to say, well, a lot of the industries that depend on these types of conventional resources, you can get away from that. So it effectively is headed towards that inevitable renewable energy future. But to do that, you need to be really clever and smart about how you might keep businesses operating through that transition period while you can implement new solutions.
And there was sorry, yes.
If I could just pick up on that a little, I don't think you'll see much more development of fossil fuel-powered power stations in Australia. There might be some open-cycle gas, possibly, as a peaking fuel to fill the gaps in what's an inevitably still variable output from renewable energy. And indeed, we've already heard announcements of the mothballing of some of the production units of the brown coal power stations. One of the great things that has emerged, I know the price increases have been very painful and they're not actually linked at this point to the carbon price so much as wires and poles, is that the actual consumption of electricity in Australia has stabilised and might indeed have fallen over recent times, which means that as we add renewables, get to the 2020 target, we're in fact eating back into that base. So I suspect what will happen is it will run the old coal-fired power stations into the ground, and unless they can come up with carbon capture and sequestration at a reasonable cost, you won't see much new. If they can do carbon capture and sequestration, again, that comes, and you can do it reliably and relatively as cheaply as you can do renewables. Again, that's another way of providing power without necessarily harming the atmosphere.
And there was a gentleman at the back. Thank you.
Hi, my name's Dan Monceau. I'm a documentary filmmaker based here in Adelaide. I've been looking at the forecast for the expansion of the mining industry in South Australia. The plan is to go from 19 operating mines to 40 by 2020. A lot of these mines are in remote areas and freight corridors are being planned as we speak. I was wondering your opinions and if anyone had done any calculations comparing road-based freight to rail, to slurry and to ship, that is marine freight, in terms of its carbon footprint.
I'll have a general go. I don't have details in that particular area, but I just want to comment on Australia's emissions overall. If you look at the last year or so, or last couple of years, we see that emissions from the electricity sector, which have traditionally been very, very big in Australia because we've depended on coal, they've reduced, and reduced now quite significantly. Our emissions continue to grow very slowly, though, because of a big increase in aviation and in diesel use in mining. And because mining is a very big energy user, it's tremendously important that we do mining as efficiently as we can in terms of greenhouse gas emissions. So I think that probably in future there's going to be an increasing focus on this. by people, because we see we're starting to win the battle in one sector of the economy, but other sectors aren't going quite so well. So I think you're quite right to focus on that issue as something that we need to tackle in future.
And that also highlights, I think, the reality that the 5% reduction by 2020 for a place like Australia is as significant as the Europeans dropping by 30%, because our business as usual would be some 25% above. So you're actually talking about a real reduction against business as usual that's pretty substantial in Australia, and that takes into account a lot of the growth in transport activities and mining activities.
And finally, can I just add that for those three choices, it will depend entirely on where you are, how far you're moving it, what you're moving, and so on. And the best way of getting people to make that choice wisely as they're investing is to make sure that the carbon emissions that are embedded in those alternatives are properly and fully priced, so that they have to bear it into account as they make that decision.
And to this ma'am just here with the white scarf. No, just behind you. Yes, there you go.
Thank you. Philippa Rowland, 100% Renewable Campaign, Repower Port Augusta. I was a little concerned to hear one thought put forward that we should be going down the track of today's lowest cost solutions, because if we do so, we may not have tomorrow's solutions ready when they're needed. So on the backdrop of having heard Pap Cannadale talk about us already being on track, still at the 3% increase in greenhouse emissions, and the latest Guardian Weekly, which has America moving towards energy self-sufficiency using gas, my question's actually a positive one. If we're going to be harnessing enough collective will to achieve that activation energy, to bring those new technologies on stream fast enough to have them ready, what benefit do you see in having some small regional examples that can actually show that a transition towards 100% renewable, with the employment, education and manufacturing opportunities that spin off it, as in Port Augusta with solar thermal, what benefit do you see in harnessing national will to get some of these demonstration projects up and running?
Yeah, I made the comment about the lowest cost solution, but that's predicated on having a target that's firm, so having a cap. So as we've said, by 2020 we want to have the 5% reduction, and then within that you try and find the lowest cost solution. And if you have an emissions trading scheme, for example, the price then is set to drive you to a solution that'll give you the 5%. And as we go out to 2050, the current government target, I think, is 80%. Same principle applies. But the market doesn't always work, and I agree with that. The market doesn't always work because bringing in new technologies, there's sometimes not a first mover advantage, and it needs public support to sort of get you over what we call the technology valley of death. And for example, solar panels were not the cheapest form of renewable energy for a long time, but then the fact that it was pushed in many European countries and around the world meant that the production costs came down, so it's now very, very competitive. And likewise with some of these new technologies, they will need a nudge, they will need pilot plants, and Australia's contribution to that is very important. We just must make sure that we pick things that actually we've got something unique that actually makes this the right place in the world to do it, and it needs to be focused rather than us trying to solve all the world's problems at once. But pilot plants, whether it's solar thermal or whether it's as we have in Australia the CO2 sequestration, those are valuable because they actually prove up the technology that allow you to then broaden it at a wider scale and make it ultimately economic.
And we have time for 3 more questions. So here in the blue shirt, thank you.
Alistair Lee, I live in the Adelaide Hills, and I'm interested in hearing about adaptation, and perhaps for Tim and Leslie, how resilient are our native plants and animals and birds to what we see coming?
I'll take that one. Well, the answer, like most answers, is it depends. Coral reefs, for example, are extremely vulnerable, and if we get a 2 degree of warming, we could actually lose most of them because they'll bleach every year until they can't recover from that. There will be some other species that are advantaged by warming and may become so advantaged that they become weeds and pests. So it really depends entirely on what you're talking about and where. There's been quite a number of estimates, however, of extinction rates, potential extinction rates of species in the future, and those numbers are very scary. So in the last IPCC report, for example, indicated that with a 2 to 3 degrees of warming, we could commit 20 to 30, somewhere between 20 and 40% of global species to be at risk of extinction. We have already lost species because of warming, and we're losing species anyway because of other human activities. But the really sort of tough thing about climate change is that we will almost inevitably accelerate those species extinction rates. So, climate change is thought of as being an environmental problem. It's really a biodiversity problem as well as a problem for our economy and health.
Yes, sir, here in the front row. That's all right, if you just hold the microphone's on, sir. If
Hello?
you just hold it, that's right, thank you.
My name is Edward Cranswick. I'm a geophysicist, and I spent 22 years working for the largest terrorist organization on the planet, the United States government. And my question, I mean, the thing is that as an individual consciousness, I get information from two sources, from my immediate sensing of the environment, and also from what people tell me, and what mom tells me, what the teacher tells me, what the boss tells me. So often these information conflicts. How do we make sure that we can get a word directly from the environment? I mean, I studied earthquakes. You don't need the US government to tell you there's a strong earthquake that's just killed you with a collapse. So how do we, in some way, make sure that we're getting information from the earth and not from people who are prostituting the earth in order to work their way into the social system?
I think that's a fair question, and I'd like to try to address that one, and do it in a way by analogy. But first to say, one of the problems we've got with seeing a changing climate is that many people nowadays don't live very close to the earth. The people that Jerry spoke about who live on $1 a day, they do live very close to it. They watch it very carefully, and they can tell you about the changes that are seen. For people in the West, we can go into an air-conditioned building and avoid the worst of it, and we don't actually see it quite often. But a lot of the changes as well, we sense globally. Like, I've never been to the Arctic ice cap. I haven't seen it melt. I've got to rely on the images, And I remember when I was trying to come to terms with this about 10 years ago. I was here in South Australia. I went to see my doctor because I wasn't feeling too good. And he took my blood pressure and he said, "My goodness, you've got high blood pressure." And I said, "I feel fine. What's this high blood pressure stuff?" He said, "I know you won't feel anything, but you've got high blood pressure. And if you don't deal with it, you're likely to die of a stroke or a heart attack or something like that." And I said, "Well, that's a bit crazy." He said, "Yes, and what's worse, you've got to take a pill every morning for the rest of your life to make sure that this doesn't happen." And I started getting a bit cranky at him. I said, "Well, that's not right." I said, "Well, what are the warning signs anyway of this heart attack and whatever?" And he said, "I'm telling you, you've got high blood pressure. That's the warning sign. Listen to me, because I know about such things, right? So this is actually a serious problem and you've got to do it." And in some ways, those health warnings are a bit like the climate warnings. We can't monitor the whole Earth. We can't see changes everywhere. Just like in our own bodies, there are changes that we're not really aware of. And sometimes you do have to take expert advice done by people who have the right instrumentation to understand how the body or the Earth system works. So my answer to the question really is that we've got to have some respect for experts. Sure, if we're living close to the Earth and there's changes we can see, that's great, but sometimes we actually do have to take the advice of those who really know.
And our final question to the lady down the front, please, with the red shirt. Thank you.
Hello. Hi, my name's Felicia from Adelaide Hills as well. I just wanted to ask about post-oil, like how do we live since all our clothes are made with oil, and how we transport, the transport that we use is made from machines that use oil and everything. How does our culture socially and ecologically and everything adapt to a post-oil world?
Yeah, like one thing I have learned is if you try and predict the future, then there's one thing that's certain about it: you're going to be wrong. But it's pretty clear that there are a lot of emerging technologies and opportunities. So in the short term, increased hybridisation of cars is going to got the potential to dramatically reduce the use of oil in cars. So in 20 years' time, we could see cars that are running on 20% of the fuel that they would use today to do a similar thing. There's some really exciting work done on second generation biofuels. So you still may see internal combustion engines there and biofuels that are created with a zero carbon footprint. That has potential. If you've got an electricity system that is 100% renewable, then you've got electric cars, and that technology is proven today. It just hasn't, the cost of the batteries hasn't got down to a level that makes it 100% competitive. So you're seeing all of those things play out. I think another thing is that we've thought about our cities in a certain way, and one thing I see that's lacking is the short-termism that when we're thinking about the growth in our cities of the future, because let's face it, around the world we're becoming increasingly urbanised, and probably not enough thought has been given as to what are the transport options for the future, public transportation versus the things that really need the flexibility to be on road and so to speak. So those are all the sort of considerations that need to be brought into play, and I think one of the key things is that we think we need to think beyond our own needs today, and we need to try and get on the front foot on these things and think 30 years down the track instead of thinking through the next electoral cycle. And I think that's one of the big issues that we have to face. And I don't think that we've been very good at it. And I have to say the Western-style democracy is one of the areas that's where you are getting a lot of short-termism in politics. And I think that we're going to need to do better than that. I think if we are actually to have a future that's quite different to what we've got today.
I think, taking that sort of a step forward, if we are saying, look, businesses are going to look at new opportunities. Let's give a simple example. Jerry talked about biofuels. There's already opportunities around, for instance, bioenergy being harnessed out of sugarcane bagasse. So what that then means is that if there are businesses that are looking at local opportunities so that you're being much more creative in the way you meet your demands for resources, whether it's energy resource or water or materials, whether it's through reducing your energy requirements or recycling water and materials, I think that's all around local sort of creativity, and I think there is a lot happening within business communities because it's actually starting to make economic sense. So in fact, that's the critical thing here, that we want to be able to make sure that all of these new strategies that we're thinking about make both environmental as well as economic sense. And yes, that requires creative thinking, but I think businesses are already doing that.
We have time for one more question from the floor. We can ask Sir here with the blue shirt. Thank you.
My name is Graham Smith. I'm from Point Pass in the 130 kilometres northeast of Adelaide. The Development Assessment Panel of the Goyder Council has rejected an application for a wind farm at Stony Gap recently at a public meeting. The submissions from people who are affected by them was very persuasive, and it persuaded 3 out of 5 to knock back the application. That was noise. There are two
and what's
other
your question? Sorry, sir. Yeah.
Well, the noise, environmental issues, they're incredibly destructive in erecting them, and the effect on wildlife. It wrecks environments. What's happened now is that everything's gone quiet. True Energy is the company, a coal mining Chinese company, has appealed, and it's gone. The secrecy has resulted. In China, if people object to power stations, the Chinese authorities get very rough with them. I think they even kill some people.
And what would you like to ask the commissioners?
Yes, well, here they ignore us, you see. It's gone secret now.
What would you like
True
to ask
energy,
the commissioners?
well, can we entrust our future to large capitalist private corporations to protect us? I mean, the regulations they classify the Goyder region as sparsely populated. Now, some of the people there are going to be seriously affected by wind turbines. They have...
so your question is, can we trust the corporation?
I'm just trying to explain that 3 or 4 generations of farmers here, and they're surrounded by... The potential is to be surrounded by wind farms. And what's happened, of course, is that these energy companies, these large corporations, go in and offer people, landowners, very large amounts of money. If you've got 10 turbines, you're looking at $100,000 a year for 20 years. I mean,
so we'll hand over to the commissioners to respond.
Can you trust these companies to behave properly?
Thank you.
And I just want to comment briefly on the first point is that any industry that's operating needs to operate within a good regulatory environment where those externalities are taken into account. It doesn't matter whether you're burning coal and releasing particles that give people cancer or whether you're running wind turbines or whatever. We need a good regulatory environment, and that's clear. We can learn a lot from the rest of the world in this space. One of the examples that really stood out for me, I was in Scotland earlier in the year, looking at community engagement over wind farms there, and it was quite interesting because a lot of people in the Scottish Highlands didn't want large wind farms near their villages, but they were quite happy to have small wind turbines right next to their house as long as they owned them and they were deriving the profit from them. So I think there's a whole lot of issues that are mixed up with this, which are around power, your own sense of empowerment versus being imposed upon by industry or whatever else. But the reality is what we're seeing now in the world is the growth of prosumers in energy. It is people who both produce and consume. And I think that's going to be a big challenge to energy companies in future, actually. Maybe not this year, maybe not this decade, but in future, it's going to change the way we use, distribute and pay for energy and generate it. So there are other options. There are other, and perhaps it's worth exploring.
It might be reassuring, but the Senate has just released a Senate committee, a report into the health effects of wind turbines after a very careful examination of witnesses right across the board, and they've reached the conclusion that there is no reliable evidence that ultrasound or that the low frequency sound is actually physically causing health problems, although there's often stress associated with wind farms for other reasons, particularly if people feel that they've not had an appropriate level of control or input into the development of the wind farm. So that perhaps these farms are at extreme density through most of Western Europe, and people and animals seem to sheep are peacefully grazing beneath the turbines. Perhaps it won't be so bad as some of us think.
Well, if I can hand over to Professor Flannery to wrap up tonight's event with a question, if that's okay, Professor Flannery. Just some alarming figures that were released this week from the International Climate Change Talks. I'm sure many people here would have heard of this report, showing that global temperatures are on a course to rise by 4 to 6 degrees by the end of this century. Have we reached a tipping point? Is there no hope left, or what do you think is the global situation now?
Thank you. What a question to end on. I wouldn't be here tonight if I thought we'd reached a tipping point. I'd be sitting on a beach somewhere, living out the rest of my life in great comfort. So I don't think we are at a tipping point yet. But what I can say is that this decade is absolutely critical. It's the actions we take this decade that are going to have a big, disproportionately large impact on the future and future outcomes. And that's why I'm here tonight, and that's why the commissioners are here tonight, because we want to see the best outcome for the planet. We know that countries can decouple their economic prosperity from the burning of fossil fuels. We've already seen that with a dozen OECD countries. Energy use and prosperity are starting to decouple, and that's what we need to see in the world over the next little while. I just want to finish by congratulating South Australians on the leading role you've taken, not just in this country but worldwide, in terms of developing renewable energy resources. It's been fantastic, and yet we're only at the beginning of a journey. There's lots more which needs to be done, and it's been touched on by some people here tonight. Could I thank you all for your participation, the diversity of questions. It's always fantastic to get questions from right across the spectrum, from the science through to various technologies and so forth, and economic issues. Thank you. Please join us for a cup of tea afterwards and talk to myself and my fellow commissioners, because I'm sure there's many, many more questions we didn't get a chance to investigate. Yes, thanks. Thank you. Yeah.
Thank you very much for your participation tonight and for the really well thought out questions. And please remember your feedback forms. Remember to go to the Climate Commission website, climatecommission.gov.au, and you'll see vision of tonight's forum